Okay, let's begin the review for test 6. Alright, problem number 1 says we're to solve the equation over the set of complex numbers by completing the square. Recall that complex numbers means that you could get imaginary numbers as your solution. Okay, so step 1 to completing the square is to make sure that you have a leading coefficient of 1 in front of the x squared term. We do. Step 2, isolate the constant, mean bring it to the other side. And during this step is when I put my blanks in to where I will complete the square. So I subtracted 8 to get the constant to the other side. And now let's complete the square. That means fill in the blank. We do that by taking half of the linear term. The linear term is the term with the x to the first power. So half of 6 is 3. 3 squared is 9. So whatever number I added to this side, I must add to that side. Okay, sorry about that. So now what we do is we factor the left side, and remember it always factors to a quantity squared. That's why we completed the square. So to factor it, you take the square root of the first term, which will always be x, or whatever the variable is, square root of this term that you just completed the square with, so that's 3, first sign, plus quantity squared. Bring down the equals, add the numbers here, and now we solve by using the square root property, because now you have an isolated quantity squared. So to get rid of the squared, we take the square root of both sides. Well, the square root of a squared is just going to give you x plus 3. And don't forget on this side we're taking the square root, so we need to take into account both the positive and the negative. So that would be plus or minus 1, because the square root of 1 is plus or minus 1. So now we'll solve this equation by subtracting 3, and we have two possible answers. Positive 1 minus 3, well that's negative 2. Negative 1 minus 3, that's negative 4. Those are the two answers to that problem solved by completing the square. Okay, let's try another problem. Same directions. This time we have a leading coefficient other than 1 in the problem, so we have to factor that out and bring the constant to the other side. So I'm going to take the 2 out of the first two terms, put my blank here to complete the square, and bring the constant over to the other side and put my blank here. Okay, you complete the square as you normally would. That is, you take half of 3. When this number is odd, it's just put it over 2, so 3 over 2, and then square that. So 3 over 2 squared would be 9 over 4. We don't really have to deal with the negative when we're completing the square part, because recall that if I take half of negative 3, I'll get negative 3 over 2, but anytime I square any number, I'm going to get a positive. So it's always going to be a positive number you're adding here. Alright, so what number did I really add to the left side? Well, it wasn't 9/4, it was 2 times 9/4, which is 9/2. So we would add 9/2 to this side. Alright, so now we want to factor. So 2, and this is going to be square root of the first sign, square root of the thing you completed the square with, quantity squared, and then add these numbers together. Negative 3 plus 9/2 will give you 3/2. Okay, we haven't isolated the quantity squared yet, so we have to divide by 2. That's going to give you x minus 3/2 squared equals 3/4. Now we have the squared isolated, so we can use the square root property. So take the square root of both sides. This side will be x minus 3/2. This side will be plus or minus something, but we need to use our techniques for taking care of that radical. So over here on the side, I'm going to simplify the radical square root of 3 over 4. So first thing I'm going to do is separate. So the square root of 3 over the square root of 4 simplifies to the square root of 3 over 2. So I'm going to put the square root of 3 over 2 here. Okay, now solve. So I'll add 3/2 to both sides. And your answer here, notice these are not like terms, so you have two possibilities for your answer. The whole number part, well, the number, not a whole number in this case, plus or minus the radical. Okay, that's one way you can write the answer. You can also put it over a common denominator. So the other way to write this answer is the common denominator of 2 and then put the numerator 3 plus or minus square root of 3. This would be the best way to write your answer, but either answer is acceptable. Okay, problem number 3. We're also completing the square. This problem is already equal to 0 and has a leading coefficient of 1, so we want to bring the constant over. So this will give you x squared minus 2x. Put your blank so we can complete the square. Subtract the 13 and put your blank on this side. Complete the square. Half of 2 is 1. 1 squared is 1. So I'm going to add 1 to both sides. Factor the left side. Add the right side. Now it's ready to use the square root property. So take the square root of both sides. Left side is just the quantity x minus 1. And on the right side we have plus or minus, and now we need to simplify the square root of negative 12. So the square root of negative 12 simplifies to negative 1 times 4 times 3. And don't forget to take the I out. Then you can never leave a negative under the radical. So square root of negative 1 is I. Square root of 4 is 2. And leave in the square root of 3. So that's the simplified form of the square root of negative 12. Okay, now solve. So we'll add 1. And these are again not like terms, so whole number followed by radical. And this happens to be an imaginary solution. Okay, last, completing the square problem. We have a leading coefficient other than 1, so we have to factor out the 6 and bring the constant to the other side. So that's going to give you x squared plus 2x plus the blank to complete the square, negative 5 on this side, plus a blank for whatever we add to the left side we must add to the right. So let's fill in the left blank. Half of 2 is 1, 1 squared is 1. This time we're not going to put 1 on this side, on the right side, because we didn't really just add 1. We added 6 times 1, so we're really adding 6 to both sides. Okay, so now we factor the left side, add the right side. Divide by 6, and now you're ready to use the square root property. So take the square root of both sides. Don't forget plus or minus, and now again over to the side we need to rationalize the square root of 1/6. So I'm going to split it up, and I need to rationalize the denominator by multiplying top and bottom by the square root of 6. So that gives me square root of 6 over the square root of 36, which is the square root of 6 over 6. I cannot cancel the 6's because 1/6 is outside the radical and 1 is in. So it's going to be square root of 6 over 6. Okay, so now we'll go ahead and solve by subtracting 1. And then write your answer, whole number followed by the radical. Again, this is okay to leave your answer that way, or it would be better if you converted the negative 1 to have a common denominator of 6 and rewrote it as negative 6 over 6 plus or minus the square root of 6. So this would be the best answer.